3.2 lesson is solving systems algebraically. So we're going to learn two methods today, substitution and elimination method. Now, substitution method is solving for a variable and then you plug this equation into the other equation. So let's take a look at this. So my original two equations is x equals 2 and 5x plus 1 equals y. Now notice this x is already solved for, x equals 2, so I'm going to substitute it into the other equation. So if I label these equations, equation 1 and equation 2, I'm going to start with this equation 1 and I'm going to plug it into equation 2. So wherever there's an x, I'm going to plug in 2 because that's what it equals. So 5 times 2 plus 1 equals my y. Now I'm going to simplify this down to see what my y equals. So 5 times 2 is 10, plus 1 is 11. So my y equals 11, my x equals 2. So then that would be my final answer, 2, 1. That if I were to graph both of these lines, that would be where they cross. This is just learning a new method if I don't want to take the time to graph these two equations. Now this next one is not as easy, that there's already a variable solved for and then I can just plug it in. So I need to get a variable by itself. Now I want to look to see what is the easiest variable to get by itself. So notice the second equation, the y has no number in front. So I would probably want to get this y by itself, would be probably the quickest. So in equation 2, I have 2x plus y equals 10. So I want to get the y by itself. So I subtract 2x, subtract 2x. Those cancel out. So I get y equals negative 2x plus 10. And then from here, since I solved for the y in equation 2, I need to substitute this into the other equation. So I'm going to plug it into equation 1. So wherever there's a y, I'm going to plug in negative 2x plus 10. So I have 3 times x plus 4. There's a y, so I plug in negative 2x plus 10 because that's what y equals. And then it is equal to 12. Now notice this looks like a longer equation than what we originally started with, but instead of having x's and y's, now we just have one variable x, so we can solve for our x. So we distribute. 4 times negative 2x is negative 8x. 4 times 10 is 40. Combine our like terms, so 3x minus 8x is negative 5x. Bring everything else down. Subtract the 40 on both sides. These cancel out. We have negative 5x equals negative 28. Divide both sides by negative 5, and we get x equals 5.6. Now, this one, if we were to graph it, especially by hand, that would be really hard to get that x equals 5.6. If we were graphing using a graphing calculator, then it will be able to give us that accuracy. Now, once we get that x equals 5.6, we're going to plug that into equation 1 or 2. It doesn't matter which equation we use, whichever one looks easier. So I'm going to use equation number 2. So I have, and instead of using equation 2, this third one, that once I got the y by itself, it's probably going to be easier. So I use the third equation, sorry. So then I have y equals negative 2 times my x, which is 5.6 plus 10. So negative 2 times 5.6 is negative 11.2 plus 10. So then I get y equals negative 1.2. And my x is 5.6. So then that is my answer. Now number 3. I want to get a variable by itself to start with. So I'm going to choose equation 1 to get that x by itself. So minus 3y minus 3y, those aren't like terms, so I write them next to each other. So x equals negative 3y plus 5. Now I started with equation 1, getting that x by itself. So now I'm going to plug this into equation 2, the opposite equation. So wherever there's an x, I'm going to plug in negative 3y plus 5. So negative 2 times negative 3y plus 5 minus 4y equals negative 5. Notice I left everything the same, just wherever there was an x, I plugged in negative 3y plus 5. Now I solve for my y's. So I distribute, and I get 6y minus 10 minus 4y equals negative 5. I combined my like terms, so 6y minus 4y is 2y. Brought everything else down. And then it's minus 10, so I added 10 on both sides. So I get 2y equals 5. Divide both sides by 2, and I get 5 halves, or 2.5. So my y is 2.5. Now I can plug this into equation 1, equation 2, or this equation 3. The equation 3 is probably going to be the quickest, so I'm going to use equation 3 to plug it into. So then I have negative 3 times y, which is 2.5 plus 5. I simplify this down, so I do order of operation. So I multiply first, and then I add, and I get x equals negative 2.5. Now make sure to start off with, I need to make sure that I'm using both of the equations. So if I solve for an equation, a variable in one of them, I had to plug it into the other. But once I get one of the answers, then from there I can plug that back into equation 1, equation 2, or equation 3. It does not matter. Now the next method we're going to take a look at, instead of substitution, is going to be elimination. Now elimination works really nice if your equations are in standard form. So for elimination, you want to eliminate or get rid of one of your variables. So for elimination, to start off with, you want to make sure your like terms are lined up. So my x's are lined up, my y's, and then my numbers. They all need to be lined up. And then from there, you want to try to eliminate one of your variables. So you make a huge addition problem. So 4x minus 4x, those just cancel out. And then 2y plus 3y is 5y, 9 plus 16 is 25, and then I just go and solve for this equation. So they're multiplying, so I went ahead and divided by 5, so 25 divided by 5 is 5. So now that I get y equals 5, I can plug that back into 1 or 2. It does not matter, whichever one looks easier. So I used equation 1, so 4 times x plus 2 times my y is 5, so I substitute that in, equals 9, and then I just continue to solve for my x. So 2 times 5 is 10. I brought everything else down, and then they're adding 10, so I subtracted 10. These 10s cancel out, so I get 4x equals negative 1. They're multiplying by 4, so I divide it by 4, and I get x equals negative 1/4. And then my y was 5, and so then that would be my answer. My answer is going to look the same. It's going to be a coordinate. Think that I could graph these two lines, and it's where the two lines cross. Or I can use substitution or elimination. Either method, I'm going to get the exact same answer. Now number 2, I line up my like terms. Now my y's cancel out on this problem. Those are opposites. So I have negative 2x plus 5x is 3x, negative 8 plus 20 is 12. Divide both sides by 3, and I get 4. So x equals 4. Once I get that, I can plug it back into equation 1 or 2. So I plugged it back into 1 again, so negative 2 times 4 plus 8y equals negative 8. Negative 2 times 4 is negative 8. And then I brought everything else down. Add 8 on both sides, those cancel out. So 8y equals 0. Divide by 8. 0 divided by 8 is just 0. So that is my y. And so my coordinate is 4, 0. Now, you're probably trying to figure out what if something doesn't automatically cancel out like the first two examples. So this third example is, what if my x's nor my y's cancel out? What do I need to do? So if you get a problem like this that they don't automatically cancel out, you can still use elimination. You just need to force something to cancel out. So what I mean by that, we can either get our x's or our y's. So since my x's are smaller numbers, I'm going to choose my x's, but it doesn't matter. So I have 2 and 3. So what's the smallest number 2 and 3 go into? 6. So I'm going to make one of them a positive 6x and one of them a negative 6x. So to get 2 to 6, I need to multiply it by 3. And then to get to 3 to negative 6, I need to multiply by negative 2. So then I have a positive 6 and a negative 6, and then it would cancel out. Now I can't just multiply the 3 by this term and the negative 2 by this term. I'm going to have to distribute that to all 3 terms and distribute this to all 3 terms. So when I do that, I get 3 times 2x is 6x, 3 times 7y is 21y, 3 times 4 is 12. And then multiply this one by negative 2, so I get negative 6x minus 10y equals 10. Now I can go and solve it just like the first two examples, so that my x's cancel out. 21 minus 10 is 11. Y. 12 plus 10 is 22. Divide both sides by 11. 22 divided by 11 is 2. Now once I get one of them, I can plug this y equals 2 in equation 1, equation 2, or this equation 3, or this equation 4, whichever looks easier. So I'm going to plug it into equation 1. So 2 times x plus 7 times 2 equals 4. And then I simplify this down and solve for my x. So I get 7 times 2 is 14. I subtract the 14 on both sides. Those cancel out. 4 minus 14 is negative 10. They're multiplying by 2, so I divided both sides by 2. Negative 10 divided by 2 is negative 5. So my x is negative 5, and then I write my final answer as a coordinate, so negative 5, 2. Now let's try another one that something doesn't automatically cancel out. So I have this new system here. You'll notice my x's nor my y's cancel out. So for this one, what I'm going to do, right here I have 1x and 8x. So I'm going to multiply this top one by negative 8. So then I would have a negative 8x and a positive 8x. Now if I didn't do that, another option that I could have is negative 4 and negative 5. 20 is the smallest number that they both go into. So I can multiply one by 5 and one of them by negative 4 to have it be 20y and negative 20y. So that would be another option. But if I multiply this top one by negative 8, I end up with negative 8x plus 32y equals 32. The bottom one, I just wrote it the exact same way. Now my x's cancel out. So I have 32y minus 5y is 27y. 32 plus 22 is 54. I divided both sides by 27, so I get y equals 2. Now once I get that y equals 2, I can plug that back into equation 1, 2, or this 3. So I used equation 1, so x minus 4 times 2 equals negative 4. So I have x minus 8 equals negative 4 plus 8, I get x equals 4, and then I write my answer as a coordinate. Now the final type of example that we're going to go through in this lesson is some different unique solutions. So what I mean by that, we'll take a look with this first example. Notice they look just like the last couple examples we've been going through. This one's really set up nicely to do elimination, so I'd go ahead and eliminate. But on this one, if you're starting to notice that my x's are going to eliminate and my y's are going to eliminate. So what I'm left with is 0, and then negative 5 plus 5 is 0. All my variables cancel out. And so 0 equals 0, that's a true statement. So I would either say it's always true, or if I would graph it, it would be the exact same line, or it's dependent, or there's infinitely many solutions, depending what the question is asking. So if the directions are saying, is it always, sometimes, or never true, this one would be always true. Every single number works. If they want you to graph it, you would just say it's the same line. If they want you to know, is it dependent, independent, or inconsistent, you would say it's dependent. And if they ask you how many solutions it has, you would say there's infinitely many. Now this next one is set up nicely that for elimination. Notice for this one, the x's and the y's cancel out again. But on this one, I get 0 over here, and then 6 plus 10 is 16. Both sides don't equal the same like up above. So if both sides don't equal, then it's going to be always false or never true. And then if I were to graph both of these, they're parallel lines. So they're never going to cross, they're inconsistent, or there's no solution. All right, this final one we're going to take a look at. Notice nothing cancels out, so I need to force something to cancel out. So this, when I'm taking a look at my y's, I'm going to multiply this one by negative 3 so that when my y's cancel out. So I have positive 3y and negative 3a. So I'm going to distribute this to everything. So I get negative 12x minus 3y equals negative 18. Notice my x's cancel out, my y's cancel out, so I get 0, and then negative 18 plus 18 is 0. Both sides equal the same, so it is like number 1, that it's always true. It's the same line, it's dependent, and it's infinitely many solutions. Now you won't have to write all of these, just look at the directions. What are they asking you to find?